Hey everyone, welcome back to my YouTube channel. This is Lovaltapi studying in Sri Venkateshwara College of Engineering. Today I'm here to teach you about the topic Rook polynomials regarding the subject discrete mathematical structures. Introduction to Rook polynomials. What are Rook polynomials? Rook polynomials are generating functions used to count the number of ways to place non-attacking rooks on a chessboard like grid. Why are they called rook polynomials? Because they are based on the chess rook's movement vertically and horizontally and deal with placing rooks so that they don't attack each other. Why study them? They are useful in solving problems related to permutations with restrictions and are an important concept in combinatorics. Basic concepts. Chessboard model. Consider an m into n board. Each square can either be available or blocked. Non-attacking rook placement. Rook attack along rows and columns. So a placement is valid only if no two rooks share the same row or column. Board configuration. Rook polynomials can be computed for full boards or boards with certain squares removed, called Ferris boards. Rook polynomial definition. Rook polynomial, that is R by bracket b comma x, that is equals to r0 plus r1x plus r2x squared plus and so on goes for rkx to the power k, where rk is equals to number of ways to place k non-attacking rooks on board B. Meaning of coefficients. R0 is equals to 1, that is one way to place 0 rooks. R1 is equals to number of ways to place 1 rook, and R2 is equals to number of ways to place 2 non-attacking rooks, etc. And this polynomial degree is nothing but a maximum number of non-attacking rooks that can be placed. The usage of this is, this encodes rook placement counts compactly for combinatorial analysis. Now let us see the example to understand it better. Now taking example 1 as 2 into 2 full board, R0 will be 1 and R1 will be 4 and R2 will be 2. Only two ways to place two non-attacking rooks. So then our formula will be 1 plus 4x plus 2x squared. And for 3 into 3 board, you can list possible rook placements for 1, 2, and 3 rooks, and there are 6 ways for 2 rooks and 6 for 3 rooks. Now let us talk about the applications of rook polynomials. In combinatorics, it's used to solve permutations with forbidden positions, and in matrix theory, it is related to the theory of permanence and determinations, and restricted arrangement. For example, placing students in seats with some preferences or restrictions. Properties of rook polynomials. Additive property. If a board B is split into two parts, B1 and B2, which is non-overlapping rows and columns, then RB, x is equals to RB1, x into RB2, x. Recursive formula. Useful for calculating rook polynomials by reducing complex boards to simpler ones. Symmetry. Often, rook polynomials of systematic boards show patterns in coefficients. Practice problems. Now, let us take an example question like find the rook polynomial for 3 into 2 board, which is full board. For this, the R0 is equals to 1 and R1 will be 6, that is place one rook in any of 6 cells, and R2 will be 6. Choose 2 rows and 2 columns, place rooks. The first step is you have to list all the valid positions for rooks excluding the missing square. And for step 2, count placements for 0, 1, 2, and 3 rooks. And for step 3, combine counts to form the polynomial RB, X. And the answer will be for the 3 into 3 board, which is missing one corner square, is 1 plus 6x plus 6x squared. Why does root polynomials matter? Root polynomials turn a counting problem into an algebraic object. Once you write the polynomial, you can extract how many rook placements exist for a specific number of rooks and patterns or identities that connect rook placements to other combinational problems like permutations with restrictions. A rook placement means putting one or more rooks on the board B such that no two rooks are in the same row and no two rooks are in the same column. This ensures that no rooks can attack each other, just like in chess where rooks attack along rows and columns. Now let me conclude this by giving you a short summary. Rook polynomials help count non-attacking rook placements. They are generating functions like coefficients represent number of placements. They are useful in restricted permutation problems and combinatorics. They're conceptually related to chess but deeply mathematical. Thank you everyone. Thank you for watching my video. I hope this helped you along to your academics. Thank you for watching.